All right. So this was a question which most of the students have posted to our hotline number asking doubts regarding this. So I thought of making a video to explain on how you can get the logic behind this kind of question. Okay, so first let's read the question. It tells us a solid metal cylinder of radius r and height h is melted down to form identical small cones. If each cone has a radius half r and a height 1/4 h, how many such cones can be made? So first of all, we have a metal cylinder. We have a metal cylinder in which the radius is r. The radius is r and the height is h. Now what they're doing is they're taking this metal cylinder and completely melting it down. They're melting it down completely and using that metal, they are making n number of cones. They are making n number of cones. That means n means any number like 1, 2, 3. So they're making cones. The cone's radius is half r. That means half of the radius of the cylinder is the cone's radius, and the cone's height is 1/4 h, which means 1/4 times the height of the cylinder. So this is the logic we have to get. We melt down a complete metal cylinder and get some number of cones with these specific dimensions. So now let's write the logic. First of all, in our part 2 paper, most of the time they give the formula for volume of a cylinder and volume of a cone if they are giving this question. But we all know that volume of a cylinder is pi r squared h and volume of a cone is 1/3 pi r squared h. So first we write a simple relationship pi r squared h. That means volume of the cylinder is going to be equal to n number of volume of cone 1/3 pi r squared h. And then you actually replace the real radius and height pi r. In this case also the radius is r, so you just can repeat it as r square. H height. In this case also the radius is h. But let's say in case of h, without h, let's say it was b. Now you don't go and write h over here. It will be b. Don't confuse about the r over here and the r in the formula. This is a universal r and this is an r used in this specific question. Let's say in case this was not simple r and this was capital R. Now we can't use simple r here. We must use capital R here. So just keep those things in the mind. Don't get those things confused. So we have pi r squared h over here and n number of 1/3 pi, and in here r is not just r, it's half r. So we write half r squared and h is 1/4 h. So 1/4 h. So you can simply cut in this step, but let me take another step to explain it perfectly. So pi r squared h is going to be equal to n into 1/3 pi. So you square this, which is going to be 1/4 r squared. You can use multiplication symbols in between if you like. So 1/4 r squared into 1/4 h. So you can simply next cut down pi r squared h h. So the remaining balance in this side is going to be 1. So next you can write 1 is equals to n into 1/3 into 1/4 into 1/4, which is going to be 1 equals n into 1/48. So you move 48 to the other side, n is going to be 48. So you can make 48 cones using the metal melted using this cylinder. Like using this cylinder's metal, you can make 48 such cones. So that was the base idea. Again, if you ask me like, do you need to mention every step in this? Like, I can, if you can simply mentioning this step is important. Like, you have to apply the theory to the question. Like, do I need to mention a separate step for cutting, a separate step for multiplication? Like, if you can jump from here to the final answer, also it's fine. But writing more steps is better in case if your final answer is screwed up, you get you end up getting marks for your work. So let's meet with another question. Bye bye for now.